In this video, I'm going to work an example from your homework, question number 19 from section 17. It's to solve the inequality and write the solution set using interval notation. We have a rational inequality, which is the expression 5 minus x divided by the expression x plus 1 is greater than or equal to 0. To solve this rational inequality, we need to first find the boundary numbers. The boundary numbers come from where this quantity, 5 minus x divided by x plus 1, is equal to 0. And then also where the function is undefined, and that is where x plus 1 is equal to 0. So in the first equation, 5 minus x divided by x plus 1 equals 0, when we cross multiply, we just get 5 minus x is equal to 0. Adding x to each side, we get 5 is equal to x. X plus 1 is equal to 0, and x equals negative 1. So our two boundary numbers are negative 1 and 5. We place these numbers on a number line in numerical order, so negative 1 and 5. This divides our number line up into 3 regions. We'll label those as A, B, and C. Now we need to test a point from each of these regions to determine where the solutions are contained. Region A is the interval from negative infinity to negative 1. So a test point from region A would be negative 2. When we replace x with negative 2, in the original inequality, we get 5 minus negative 2 divided by negative 2 plus 1, and we're asking ourselves, is that greater than or equal to 0? This simplifies to be 7 divided by negative 1, and that's negative 7, which is not greater than or equal to 0, so that is a false statement. Region B is the interval between negative 1 and 5. So a test point out of that region would be 0. Replacing x with 0, I get 5 minus 0 divided by 0 plus 1. Is that greater than or equal to 0? Well, that simplifies to be 5 divided by 1, or 5, which is greater than or equal to 0, so that is true. And then in region C, we have numbers to the right of 5, or 5 to infinity. A test point in that region would be 6. Substituting 6 for x, we get 5 minus 6 divided by 6 plus 1. Is that greater than or equal to 0? Well, that's negative 1 divided by 7, or negative 1/7, which is not greater than or equal to 0, so that is false. So the only solutions lie in the region that tested true, which was region B, so that is between the negative 1 and 5. Very important here to now think about what happens with your endpoints. Are they included or not, especially with rational inequalities? My inequality is greater than or equal to 0, which means I can include the solution that makes that equal to 0. So that whole expression is equal to 0 at 5. So this can be included. However, negative 1 was a value that makes the expression undefined. We can never include a value that makes the expression undefined in our solution set. So this one has to be excluded. So I will have a parentheses on negative 1, but a closed bracket on 5. So my solution set is open parentheses, negative 1, comma 5, close bracket. So this is everything between negative 1 and 5, excluding negative 1, but including 5.